Hey guys, these are your electricity introduction notes. So you can title it that right now and then get going. So the first thing I want to talk about is conductors and insulators. Circuits are made of both of them, actually. Conductors basically conduct electricity, and I provided some examples of conductors below: copper, aluminum, platinum, gold, silver, water, most water, people, animals, and trees. Silver is actually the best conductor of electricity. So the question becomes, why don't we make wires out of silver? And you might think it's pretty simple because it's too expensive to make a lot of wires out of silver. So generally, we go for a good conductor like copper, which is less expensive but still a very good conductor. Insulators do not conduct electricity. So what they do is you could wrap conductors in insulators and you've got a wire, right? Examples of insulators: glass, dry wood, not wet, plastic, and of course rubber. It does not conduct electricity. Cross section of a wire here. So you could see here that a wire is made of a conductor and an insulator. Inside the wire, you've got the metal, which is a conductor. I want you to draw this little diagram just showing the conductor is always in the middle of the wire, but so you could handle wires, wires are intentionally wrapped in rubber, which is an insulator. Rubber. So electricity, depends on both, conductors and insulators. A circuit depends on both. Metal inside of the wire to conduct the electricity, insulator so you could touch and use the wire. Okay. Here's a circuit diagram, alright? And there's a number of important parts to a circuit. I want you to draw both of these diagrams. What makes a circuit, work, and what makes it, not work or not light a light bulb. Well, a circuit needs to have an energy source. That could be a battery. It could be the hand crank generator you used. It could be a power plant. But some energy needs to come from somewhere to be put in a circuit to come out in the other end as light, if it's a light bulb being powered. A resistor. An example of a resistor is a light bulb. Another example is a TV or a toaster or a fan, something that is being powered by the energy source. And then wires to connect the energy source to the resistor. Alright. The wires need to be connected so that you have a closed circuit in order to light the light bulb. Here, a closed circuit, you could draw it like this. The light bulb is lit now. A closed circuit, add this to your diagram, is when the switch is down. It's closed, like a door. And what that does is it makes a complete loop. A complete metal or conductor loop. When you have that, you have the light bulb lighting. But when the switch is open, or like a door, it's open, you can see you have a broken loop. So a broken loop means it won't light here. And that's called an open circuit. See, our energy source here is a battery in each diagram. Notice also how the wires are connected to the light bulb. We're going to do that soon. What's the purpose of a circuit? Well, the purpose of a circuit, it's pretty obvious. I mean, you have circuits in your own home. What's the purpose of having them? Does anybody play Xbox? Well, it wouldn't work without plugging it into a wall, right? Anybody watch TV, charge a computer, use a refrigerator. They're all plugged into the wall, into a circuit. So the purpose of a circuit basically is to get energy, or to use energy. So what a circuit does is it converts energy from one kind into another. It takes energy that is in fossil fuels, that is, coal or oil, right? Nuclear energy, natural gas. Maybe if you've heard of fracking, it's a controversial topic, to get natural gas out of the ground and use that at a power plant. Wind energy, solar energy, even a water wheel is an energy source, and it takes these wind and water wheel. They're kind of like your hand crank generator in the lab. They're kinetic energy, motion energy. But what a circuit does is it always takes some energy source, converts it first to electrical energy. That's the electrons moving through, jumping from metal atom to metal atom, in that wire, and they're taking that energy on their backs that started out in all these types of sources. And in the medium is electrical energy. It carries it. That's what a medium is. It says, well, for a while I'm going to carry the energy before you use it. And then when it gets to energy use, it drops off that energy in your house in a resistor. That is a TV, fridge, toaster, light bulb, etc. So there's always 3 steps to a circuit. There's some energy source, there's the medium in the wires, and then there's the energy use. But in fact, the same energy that comes out as light in your television started out in coal and oil and a fossil fuel, especially for Hillsdale. What's inside a light bulb? Alright, so draw this diagram of what is inside a light bulb, and just look at some parts. There's a metal tip on the base, there's insulating material above that, then there's metal again around the base, there's a glass support, and on top of that is a wire that goes up into a filament, and it goes from the side up to the filament and down to the bottom. And the filament is an important part, the super important part of the light bulb. It's a metal wire which glows inside of a light bulb, and it's usually made of tungsten, the hardest metal on the periodic table, and it has the highest melting point also. And that's very important because when electricity travels through that filament, that metal wire, that very, very thin metal wire, it doesn't melt. It's not going to happen. In fact, the filament glows, and that's what produces light. One might think, like, man, if electricity is going through that wire, I saw that happen with the steel wool. And when electricity went through the steel wool, all it did was light on fire. Why doesn't the filament, why does it keep glowing? Why doesn't it light on fire inside of a light bulb? Why don't filaments just burn up right away? It's because the steel wool lit on fire because there's oxygen in the air. But a filament inside of a light bulb is inside something called a vacuum. That's not a vacuum cleaner. But a filament, basically, it can't burn up and light on fire because there's no oxygen inside of the light bulb. A vacuum is a space containing no air. So if there's no air inside of the light bulb, there's nothing, you can't light it on fire. There's no oxygen to be consumed. So a filament glows because inside of a light bulb there's absolutely no air at all. There's no oxygen, nothing. That's what we call a vacuum, a space containing no air. So a filament glows instead of lighting on fire, like the steel wool did. And the steel wool lit on fire because there was oxygen, which isn't inside of a light bulb. One other thing I'd like you to notice about this diagram, the last thing I'd like you to notice, is that the wire which goes to the filament is connected to two parts. It's connected to the side metal and to the bottom metal. So if you make a circuit say to a battery here, and you did this with the paper clip in the lab, if you got to that part, the battery needs to be touching one part, either the side or the bottom metal, and the other end of the battery needs to be touching into the opposite end. So if this end of the battery touches the bottom metal, this end needs to touch the side metal, because part of your loop needs to go through the actual filament and then back down into the energy source. So you could see that our loop kind of goes up into the side metal, through the filament, down into the bottom metal, and back to the battery, right? So it's important to know that if you make a circuit, one wire needs to touch the side of the light bulb and one wire needs to touch the bottom.